Hello, Math Wizards! Welcome to a new lesson episode of Just Math PH. So, for today's lesson, we will be learning about nature of the roots. We can also name nature as the kind of roots or the solutions to quadratic equations. Some of the roots of the quadratic equations are actually real numbers. It's very important that we know the real number family. So let's review the real number system or the real numbers chart. Real numbers are divided into two sets. We have the rational numbers and the irrational numbers. Below the rational numbers are sets of numbers. These are the non-integer rational numbers and the integers. So non-integer rational numbers are what we call the fractions. Okay, they are the fractions. They are, example, we have 1/2, that's a fraction, or 3/4, that's a fraction. And another example of non-integer rational numbers are the terminating decimal, or these are the decimals that stops. Example, 0.25 is an example of terminating decimal. Another one, we have 3.4 is an example of terminating decimal. Another example of non-integer rational numbers are repeating decimal. So these are decimals that has digits at it that repeats. Example, 0.252525 and so on. So notice that 25 here repeats infinitely. So this three here, fractions, terminating decimal, repeating decimals, are the non-integer rational numbers. Now, how about the integers? Okay, integers are the negative numbers and the whole numbers. So example, we have the negative numbers like a -4, -3, -2, -1, and the whole numbers starting from 0, 1, 2, 3, and so on. These are what we call the integers. So we have here um, the negative numbers here and the whole numbers. Remember that whole numbers starts from 0. So 0 is an example of a whole number, 1 is an example of a whole number, and so on. Now, whole numbers are also divided into two. Okay, so as I've mentioned earlier, we have the 0 and the natural numbers. The natural numbers are or starts from 1, 2, 3, 4, 5, and so on. So these are whole numbers. Now, some of the common mistakes is that students identify as example -2.5. Is that an integer? No, -2.5 is not an integer, but it's an example of a terminating decimal. So -2.5, we have to erase -2.5 here. And okay, so -2.5 is an example of terminating decimal. So any decimal that stops is an example of terminating decimal. Now, how about the irrational numbers? Okay, so again, these are the family of rational numbers. So any number that we can't mention here or is not described here under the rational number is not a rational number. These are what we call irrational numbers. So what are irrational numbers then? Now, irrational numbers are the following. Example, non-repeating and non-terminating decimal. Okay, so what are these decimals? Example, 0.125635 and so on. So notice this is non-terminating because it doesn't stop, and it's also non-repeating because there is no digits here that is repeating, or there's no signs of repeating digits here. So this is an example of non-repeating and non-terminating decimal. So this is an example of irrational number. It's a non-repeating and non-terminating decimal. Now, another example of irrational number is example, square root of non-perfect numbers. It's an irrational number. Example, square root of 3 is an example of irrational numbers. So what is square root of 3? Okay, square root of 3, if we will write it in our calculator, that is equivalent to 1.732050 and so on. Okay, 50 dot dot dot. So notice the result of the square root of non-perfect number is a non-repeating and non-terminating decimal. So this is an example of irrational number. However, if we have here example square root of 4. Now 4 is a perfect number, and we know that the square root of 4 is equivalent to positive or negative 2. And positive 2 or negative 2 is an integer. It's an integer, and an integer is an example of a rational number, right? It could be an integer, or positive 2 is also an example of a whole number or a natural number. So if we have here the square root of a perfect number, okay, square root of a perfect number like square root of 4, square root of 25, square root of 16. So these are perfect numbers. The square root of it will always result to a rational number. So again, nature of the roots describe the kind of roots that we have in the quadratic equation. So how can we determine the nature of the roots? So first, let us know all about discriminants. So discriminant can be found in the quadratic formula. So discriminant is actually the expression inside the radical symbol, which is the b squared minus 4ac. So that is our discriminant. Now, the discriminant will help us determine the nature of the roots of our quadratic equation. So this is our discriminant, b squared minus 4ac. Now, there are things we need to consider on the value of the discriminant for us to describe the nature of the roots. Again, the discriminant is the value if we evaluate b squared minus 4ac. So it's the value for b squared minus 4ac. So that is the discriminant. Now, if the discriminant is a positive number and it's a perfect square number, then the nature of the roots would be real numbers, rational numbers, and unequal roots. Now, if the the discriminant is a positive number but it's not a perfect square number, then the nature of the roots would be real number, irrational numbers, and unequal roots. And if the discriminant is 0, then the nature of the roots would be real, equal roots. And last, if the discriminant is a negative number, then the nature of the roots are non-real numbers or imaginary numbers. Find the discriminant and determine the nature of the roots of the quadratic equation x squared minus 12x plus 36 equals 0. So first, let's identify the values of a, b, and c. So our a is equivalent to 1, our b is equivalent to negative 12, and our c is 36. So solving for the discriminant, so our discriminant is b squared minus 4ac. So our b is 12, so negative 12 squared minus 4 times 1 times 36. So simplifying it, negative 12 squared is negative 12 times negative 12, right? So negative 12 times negative 12, that is 144, minus 4 times 1 times 36, or negative 4 times 1 times 36, that is equivalent to negative 144 or minus 144. So 144 minus 144 is 0. So our discriminant is 0. So the nature of the roots of the quadratic equation x squared minus 12x plus 36 equals 0 is real, equal roots, since our discriminant is 0. So for our second example, we have here x squared plus 5x plus 6 equals 0. So let's identify our a, b, and c. Our a is 1, our b is 5, and our c is 6. So solving for the discriminant b squared minus 4ac, we will substitute the values of a, b, and c. So our b is 5, so that is 5 squared minus 4 times 1 times 6. So simplifying this, we have 5 squared. We know that that is 5 times 5, so that is equivalent to 25. Minus, so 4 times 1 times 6, or negative 4 times 1 times 6, that is equivalent to negative 24 or minus 24. So 25 minus 24 is equivalent to 1. So our discriminant is 1. Now 1 is an example of a perfect square number, right? It's perfect and it is positive. So if our discriminant is perfect and positive, meaning our nature of the roots would be real, rational, and unequal roots. For third example, we have here 2x squared minus 8x plus 3 equals 0. So the value of a is 2, our b is negative 8, and our c is positive 3. So solving for the discriminant, b squared minus 4ac is equivalent to negative 8 squared minus 4 times 2 times 3. So simplifying this, we will have negative 8 squared, that is negative 8 times negative 8. So that is positive 64. So negative 4 times 2 times 3. So that is negative 24. Now subtracting 64 and 24, that is equivalent to 40. So 40 is an example of a non-perfect number. So it's non-perfect. It's also positive. So what do you think would be the nature of the roots for this quadratic equation? So if we have a discriminant that is non-perfect and it's positive, then the nature of the roots will be real. This time it will be irrational. Irrational unequal roots. Number 4, 2x squared plus x plus 3 equals 0. So our A here is 2. Our B is positive 1 because there is an invisible 1 here. And our C is positive 3. So let's solve the discriminant. So B squared, that is 1 squared minus 4 times A, which is 2, times C, which is 3. So 1 squared is 1 times 1, so that is 1, minus negative 4 times 2, negative 8 times 3, so that is negative 24. Now 1 minus 24 is equivalent to negative 23. Right? Because 24 is bigger than 1, so we have to follow the sign of 24. So that is negative. Now it is negative 23. Now negative 23 is obviously a negative number. So remember, if we have a negative discriminant, meaning the nature of the roots would be non-real number or we have imaginary numbers.